Okay, I wanted to give you guys a few more examples of systems of equations using the elimination method and then in a little bit the substitution method. So the easiest way definitely is to graph these on Desmos or on paper, but we're going to learn two other methods as well. This is number 5 from your Dodge homework, so don't get this wrong. Before we can start, we have to have the x's or the y's coefficients match up. So right now they don't match up. 8 and -4, 16 and 2, neither match up. But I recognize here, if I can double this, it'll turn into 8 and match up. So that's what I'm going to do. I'm going to turn this into an 8x. The way I do that is by multiplying all of the bottom equation by 2. This gives me -8x when I distribute plus 4y equals -60. The top equation doesn't change. It stays 8x plus 16y equals 20. So now here are my two new equations that I'm looking at, and I see that the 8's match up, ignoring the sign, the negative sign. 8 and 8 match up. That makes them eliminatable. So if I add these two equations together, 8x plus -8x cancels out, and that gives me 0. That's what I want to happen. So 0 there, plus 16 plus 4y is 20y, equals 20 plus -60 is -40. And I don't need the 0 plus there. So 20y equals -40. Divide by 20, and you get y equals -2. That's the first half of my solution. Second half comes from when I go back to whichever equation I think looks the best. I'm going to take the top equation. It's got some positive numbers in it. And I'm going to take 8x plus 16y equals 20, except I'm going to plug in that -2 in place of my y. So 16 times -2 instead of 16 times y. That gives me 8x plus -32 equals 20. And this equation I can easily solve. Add 32 to both sides. 8x equals 52, and divide by 8. X equals 6.5. So if we want to write it in ordered pair form, 6.5 comma -2 is our answer. Number 11 now from the Dodge homework. This is probably the hard, well, not probably, this is definitely the hardest one on that worksheet. So if you get this right, you're good. It says on your worksheet to be careful. I gave you a warning here. In order for this process to work, the two equations have to be in the same form. In this case, we want it in standard form. I got the x plus y equals the number. Up here, I need x plus y equals a number. I need to get this -9 across to the other side. The way I do that is by canceling it out from the left side. So I'm going to get rid of it by get rid of all that. Whoa. There we go. I'm going to cancel out the -9 by adding 9 to both sides. So now this new equation, it's going to move down here, is -7x minus 8y equals +9. Now the two equations are both in standard form. I don't need that one at all anymore. So here are the two equations I'm looking at. -4x plus 9y equals -22, and -7x minus 8y is 9. I need the coefficients to match up. So I need these to be the same or those to be the same. This is a difficult one because there's nothing I can really multiply by to make 4 turn into 7 or to make 8 turn into 9. So I'm going to have to multiply both of them by something. So I'm going to look at the x's. The numbers look a little smaller. I'm going to try to make both of these x terms turn into 28. 28 is the least common multiple. Think of like getting a common denominator on a fraction. I know I can easily get both of those to 28. So the top equation can go to 28 if I multiply that whole thing by 7. So it's going to turn into negative 28x plus 63y equals 7 times negative 22 is negative 154. So the top equation now has a negative 28x. I need the bottom equation to get a negative 28x. So I can turn in negative 7x into 28 by multiplying by 4. So there's a negative 28x. 4 times negative 8y is minus 32y equals 4 times 9 is 36. So 2 new equations over here on the right, but I have my 28x's that match up. So I'm going to eliminate the x now. They are the same sign. I know I can't add because negative 28 plus negative 28 doesn't cancel out. So adding is not the way to go. I'm going to have to subtract. So I have negative 28 minus negative 28. That gives me 0. 63y minus negative 32y. 63y minus negative 32y turns into plus 32y. So that's a 95y equals negative 154 minus 36, which is negative 190. So 95y equals negative 190, which means divide by 95, y equals negative 2. That's the first half of my answer. For the second half, I need to go back to any one of the original equations. I can even go back to the equations they gave me to start with. I don't have to use my blue equations over here. I want to choose the smallest one, and it looks like this here is the smallest one. So erase all this stuff around it. Take that equation. None of these equations really look nice, but oh well. Negative 4x plus 9y, but we're going to plug in negative 2 for y, equals negative 22. We can solve this equation. That is negative 18. Negative 4x minus 18 is negative 22. Add 18, and we get negative 4x equals negative 4. So x equals 1. There's our answer. So elimination, hopefully you guys are good with that now. We're going to look at 2 substitution examples. This is your forward worksheet. We're going to start with number 6. This is one of the, probably one of the more difficult ones on this worksheet. I know we're going to substitute something in place of a variable, but it doesn't tell me what that variable is going to be. I need to isolate one of my variables first. I need something to look like y equals this or x equals this. Neither of those are given to me, but I can see this y right here has nothing in front of it. I should easily be able to isolate that y. I can cancel out this negative 10x to get the y all by itself. And that's what I'm going to do first. I'm going to say plus 10x to both sides, and that gives me y equals 10x plus 15. Now I know what y equals, and I can substitute that in the other equation in place of y. So now if I look over here at the first equation, 2y minus 20x equals negative 10. In place of y, I'm going to put in what y is, which is 10x plus 15. So there's my y. This is a big, ugly equation, but it only has x's in it. That is solvable. So we'll distribute, switch colors, 20x plus 30 minus 20x equals negative 10. So if I combine like terms, 20x and negative 20x is 0x. So they just cancel out. I'm left with 30 equals negative 10. This is one of those special cases. 30 does not equal negative 10. 30 will never equal negative 10. So there is no x and y that will work in both of these equations because I end up getting something that can never happen. So this is no solution. Okay, with these two, to show you that it truly is a no solution, if you go to Desmos, here I just typed in both equations, the 2y minus 20x equals negative 10. That gave me the red line. The blue line, negative 10x plus y equals 15. As you can see, these are parallel. They will never cross, they'll never intersect, so there is no solution. So, no solution. Next one, number 7. This one's a little more normal of a problem. We have y equals 7x minus 6 and y equals 2x plus 9. We're going to use the substitution method to solve this, find out what x and y is. So they tell me two different ways what y is. So my first step is already done. Our first step is to isolate one of the variables. We have y already isolated right there. So I'm going to take this y right here and put it in place of that y right there. So instead of saying y equals 2x plus 9, I'm going to say 7x minus 6 equals 2x plus 9. So that is, really it's the second equation. It's like saying y equals 2x plus 9, but I substituted in for the y what it equals. So it's a big equation with only x's in it. I can solve that equation. I have an x on both sides, so I want to get rid of the smaller x, which in this case is 2x, and cancel it out. So 5x minus 6 equals 9. 6 sides, 5x equals 15, so x equals 3. The first half of our answer. I now have to go back to either equation. These both look pretty similar. Neither one looks easier than the other. They both look pretty easy. I'm going to take this equation here and say that y equals 2 times, well, instead of x, I'm going to plug in 3 plus 9. So 6 plus 9 here, y is going to equal 15. So my solution here is x, comma 15. I didn't mean x, comma 15. I meant x, comma y, which is 3, comma 15. So you can leave your solution like this. Just circle, there we go. Circle each x and each y, or you could tell me the ordered pair 3, comma 15. It's all the same information. I know what x is, I know what y is, either way. We're going to have our test next Friday, the 25th. Your homework, both homework, Ford and Dodge, are due that day. I also have sent to your Google Classroom your Cornell notes right here. You'll want to have those completed by next Friday. They just remind you how to solve using all three methods: the graphing method, the elimination method, steps, and an example.
and the substitution method, the steps with an example. So you're adding these on to your graphing Cornell notes. We took those in class last week. Add the 2 new methods on there and have that next Friday for the test. Good luck.